you can see that the circuit is powered up and nothing is happening. See, there is no LEDs on, that's perfect. Now I send some commands to turn on the LED. I send A. Okay, let me send A. I had written A, I press enter. Okay, the A is sent, and over here the first LED is on. Now I send B. I written the B, I press enter, second LED is on. Now I send C, I written the C, third LED is on. Now I send D, D will reset it back to the original state, C. Now I send only B, the second LED is on. Again I send D, D resets it. Now I send C, third LED is on, B, second LED is on, D, again it resets it back to the original state. So this is how it's gonna work here. So you can see that programming is very simple. We just initialize the software serial port and 3 LEDs, and then we are just we receive the data using this command. Then if it's A, first LED on, B, second on, C, third on, and D, the all go reset. That's all. It's simple as that. Hello guys, welcome to learning microcontrollers. In this video I will show you how you can use MikroC for PIC software serial library to read a data from PC, and then we are going to use a PIC16F877A to turn on off 3 LEDs as per the commands coming from the PC. And to connect the PIC16F877A with the PC, we are going to use a USB to TTL device. So let's get started. So this tutorial will demonstrate to you how we can use a MikroC for PICs software serial libraries read commands. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. Then this is the USB to TTL device. I'm going to use a CI340. You can use any other USB to TTL device as well. Let me label this for you as well. As you can see that it is labeled already, and it has like 6 pins like this. On the leftmost we have 5 volt pin, then VCC, then 3.3 volt pin, then TX, RX and ground pins. Now guys, as you can see that these 3 pins TX, RX and ground, they are common in all type of USB to TTL devices. Whichever you use, like FT232 or CP2021, something like that, whichever you use, you will have these 3 pins TX, RX and ground. These 3 pins like 5 volt, VCC, 3.3, they vary. In some you don't have 3.3 volt option, in some you don't have 5 volt option, etc. So but these 3 pins TX, RX and grounds are in every USB to TTL device. Now let's connect it with the computer. Now since UART, these are the UART protocol pins TX and RX, and PIC's UART protocol is at pin number C6 and C7. But we are going to use a software serial library, so we are not going to use these 2 pins at all. We will use some other pin. We will like transfer the UART function to some other pin using the software. So I'm going to use a D0 and D1, D0 for the as a RX pin and D1 for the TX pin. So this will be our software UART port. So now let's connect the device. I connect the ground pin of the USB to TTL device with the ground of the PIC. Now the RX pin of the USB to TTL device will go to the any pin that you select as the TX pin of your software serial. So I'm going to select the pin number D1 in the programming. Now TX pin of your USB to TTL device will go to the RX pin of your software serial selected pin. So I'm going to set the D0 as a RX pin of the software serial. So see the difference. Here we are taken D0 and D1 as a UART port, while the original hardware port is at C7 and C6. That's the beauty of software serial. You can turn any pin as TX and RX pin. Now guys, for the demonstration purpose, we are going to use these 3 LEDs. Let me show you. This is the one LED. This LED has 2 pins, one longer, one shorter. And to connect this with the PIC, we will need a resistor. This will limit the current going to the LED, and it can be any value from 100 to 500 ohm, or you can go higher as well. Higher the value of the resistor, dimmer the LED will go. So I will use a 220 ohm resistor. It's ideal. Now guys, let's see. The longer pin of the LED is always a power pin. The shorter pin is always a ground. Similarly, we will have 2 other LEDs as well, like this. And we have total of 3 LEDs. Now computer will send signals to the USB to TTL device, and then it will send to the PIC, and we will receive the data from the software serial port, and then we will program it in a way that when A is received, this LED turns on. When B is received, this LED turns on. When C is received, third LED is turned on. And when D is received, it will reset. All the LEDs will turn off. Now guys, let's connect the LEDs first. Now the bottommost LED, connect the longer pin to the one end of the 220 ohm resistor like this. From the other end of the 220 ohm resistor, send it to any available digital input output pin of the PIC. I'm going to use the pin number B0 like this. Now guys, for the centermost LED, connect the longer pin to the one end of the 220 ohm resistor like this. From the other end of this 220 ohm resistor connected to any available digital input output pin, I am going to use a pin number B1 like this. Then guys, for the topmost LED, connect the longer pin to the one end of the 220 ohm resistor like this. From the other end of this 220 ohm resistor connected to any available digital input output pin, I am going to use a pin number B2 like this. Now the ground pins, just common them and send it to the common ground of the PIC. In this way, our connections are completed. Now before we move on to the programming, let me introduce you to the hardware. So guys, this over here is our hardware. You can see that this is the USB to TTL device, and these are the LEDs, and there is the PIC16F877A, and rest is just a trainer board. So guys, connections are as shown in the presentation. Now guys, the point is, see that these three pins are not connected because it is getting power from the computer. Right now it is getting power from the computer, and I will power up the PIC from the PIC at 3. That's why I didn't connect these three pins VCC 3.3 volt or 5 volt, because it will automatically power up when we will connect it to the computer. So that's all. So this is the hardware. Now let's move on to the programming. For the programming, just turn on your MikroC for PIC. Let me zoom in so you guys can see better. This is MikroC for PIC version 7.2.0 I'm going to use. You can use any available version of the MikroC for PIC or the free version. So go to the file, new project. Now this window pops up, new project wizard, click on next, write the name of the project. I write read soft serial tutorial by learning microcontrollers, like this. This is the name. Now select the path where the files will be created. Select the device. I'm going to use the PIC16F877A and select the crystal. The crystal I have at the pin number 13 and 14 is 20 megahertz. So I will write 20 over here like this. Now click on next and finish. Now guys, this window pops up. Press Ctrl S to save your work before you do anything else. Now guys, go to the right in the libraries, expand the MikroE libraries, then expand the system libraries. Here you have this software UART, this check mark this, expand it. Now here you have this software UART I90 command, double click on it. This window pops up, and here in the example you have this command. See that, copy it till here. And here above you can see the description. It says that this is the RX pin, this is a TX pin. So let me show you. Now see that this is a software UART initialization command. This will initialize the software pins as software UART pins as per our selected pins. So the port we are going to use is the D, and the pin I have D0 is the RX pin and D1 is a TX pin, and the baud rate I want is 9600. And this means that if it's 0, it means it's non-inverted. If it's any value other than 0, the output will be inverted. So don't touch it, leave it as it is. Now guys, software UART port is now initialized using this command. Let me give some initialization delay. 100 will do fine. Now guys, if we go to our forever loop, write down while 1, and forever loop starts here and here. Now guys, this will be our forever loop, and this will be the one time loop. Now we initialize the LEDs. We have 3 LEDs. Trace B dot F0 equals to 0. First LED is at the pin number B0 of the port B. So this command, trace command, is the direction command. 0 means the pin has been declared as output, and if it's 1, it means it has been declared as input. And for an LED, it is always the output. Now guys, the initial state, initially the LED must be off. So I give it 0, port B dot F0, a 0 is sent to the pin in the start. So the LED must be off by default. Now I give some initialization delay, not necessary, but I always suggest you give it in the one time loop. Now copy this for the other 2 LEDs. Now the other second LED, third LED. Now the second LED is at pin B dot F1, that is B1, just make it B1. And the third LED is at B dot F2, just make it B dot F2 like this. Now guys, our 3 LEDs are initialized, our software serial port is initialized. Now let's do the programming. First of all, we will need to read the characters coming from the computer. So for that purpose, go to the software UART read command, double click on it, and this window pops up. Here you have this command over here, this one. You just copy it and paste it here like this. Now take a variable which will store the value coming from the computer. I take 2 variables, char. One is for the error, that's part of the command. Second one is which will receive the character. I name it as crack1, that is character 1. So just copy it, paste it here. It will receive the data coming from the computer, and this is the syntax of the command. You can check the error. If it's 1 or 0, it depends upon if it's correct, it means it's 0. If it's incorrect, it doesn't matter. I don't use it because it doesn't matter at all. Now guys, the next thing is we have got our data from the computer. Now we process this data. Now if the char 1, the data received from the computer, the byte, basically this is a byte coming from the computer, is A. If an A is sent from the computer, then one LED should turn on. Then the LED at B dot F0 turns on. So B dot F0 becomes B dot F0 equals to 1. Initially it was off, now it's on. Now guys, it will remain on for like I make it 200 milliseconds, and then guys just copy it. Now if the B is received instead of A, if we send a B from the computer, make it else if B is received, char 1 double equal to B, then port B, but the LED at port B dot F1 will turn on. Now if C is received, if we send a C from the computer, then the LED at B dot F2 will turn on, like this. Now guys, if the D is received, if we receive a D, then all the three LEDs will go to back to their initial state. So first of all, B dot F0, it will become 0, then B dot F1 it becomes 0. It's like a reset, that once we send D, everything will be reset to the original state. And then we have the third LED at B dot F2, like this, it will become 0. Now guys, for the software serial, remember that whatever the characters are being used here, you will, to reset them, use any character other than the one being used here. Now to reset the software serial port, I make it equals to Z, because we are not using Z here. So once it becomes Z, it's like a value which will not be in the programming. Also do this in the one-time loop as well. So when the program starts, if there is any value already stored in the char 1 variable, that will be Z, and this will not affect your programming at all. So this is simple as that. Now let's build this code and see what happens. See, nothing happened. It's correct, no error. So it's built successfully. See, it took like 1084 program words. So even in the free version as well, you can use this. Like the free version has 2K of free programming memory. Now it's built. Let's burn it into the microcontroller. Let me zoom out. So this is our PIC3 programmer tool. I go to the file, import hex file. This is the file we just created. I click on write. Okay, the new file is being written. Let's get to the hardware and see what happens. Okay, let it write the new file. Okay, it is writing the new file. Now I power up the whole circuit using the PIC3 programmer tool. I click on. Okay, it's on. See that no LED is on. That's perfect. By default, no LED should be on. All three LEDs are off. See, no LED is on. So this is good. That's why there is no noise. That's why I gave Z. Now we go to our serial terminal and send some data. So go to your MikroC for PIC tools. You can use any serial terminal. I'm going to use this one, USART terminal, or you can press Ctrl T as well. Open it, select the COM port. And this COM port is a port whichever you get when you install the driver for your USB to TTL device first time. It assigns the port to it, COM port, and you have to remember that COM port. So mine is COM4, and the baud rate we set in the programming 9600. Rest are defaults. Connect. Okay. Now what I do is that let me make it clear so you guys can see as well. So as you can see, this over here is our LED. Now I send a character A. I had written A. See, the first LED turns on. Now it's on. See, that's perfect. It's working. Now what I do is that I send D. D means it's reset. So D send. Okay, it's off. That's great. Now see, I sent an A and then I send a D. Now I send A again. I press enter. Okay, A is sent. LED is on. Now I send a B. The second LED will turn on. So that's perfect. Now I send C. The third LED must turn on. C. The third LED is on as well. See, we send A, B and C here. You can see that A, B, C. Now I send a D. So we can reset the circuit. I had written the D. Now I will press enter and it will be sent. So I press D. Now see, it has been reset back to the original state, and we are receiving this data from the software UART. We are not using our hardware UART. We can connect something else over here as well. So now I again send B, only B. Now I send B. Second LED is on. Now I send C. third LED is on. Now I send D, it will reset. See, this is working perfectly fine. So guys, this is it. This is how you can use a software serial port of your PIC microcontroller using the MikroC for PIC software serial library. In my previous video, I showed you how you can write data using this library. And now I have shown you how you can read data from this library. If you have any questions, you can ask me in the comment section. Thank you very much for your time, guys, and we'll see you in the next video.